Hello, class. This is Mrs. Levenseller, and today we are learning about systems of equations using substitution. So we're going to walk through two examples here. Please make sure you have this same paper and that you follow along with your notes as well, okay? So the steps have been outlined across the top here where it says procedure, and these are the same steps to solve any of these systems that I give you, okay, using substitution. Remember, we can solve with graphing. Now we're learning substitution, and there will be one other way we learn very soon. So here are my two equations, y equals 2x plus 4, y equals negative 3x minus 6. Now, actually, these are both in slope-intercept form, so it wouldn't be very difficult to solve by graphing, but in our case, we want to solve with substitution today. So let's look at the first step here. It says, isolate one of the variables from one of the equations. Try to choose variables with coefficients of 1 or 2 if possible. And the reason being, you want to try and avoid making a lot of fractions for yourself, right? So if you have a coefficient of 1 or negative 1, it's going to make your life a lot easier because you're only dividing by the number 1, right? So let's go ahead and look and see if we can isolate a variable. Now you could use either equation up here to isolate the variable, and you could isolate x or y. It truly doesn't matter. When I look at these equations though, I see that both of them actually already have y that has been isolated. So that first step in this problem has been done for me. So I'm just going to take the top equation and say, all right, that's the one where I have isolated the y. And I like to, when I'm doing this, put a box around the variable that I'm isolating because, hey, I know y equals 2x plus 4. And in a second, when we substitute, we want to make sure we're replacing that same variable, okay? So now, because it's a system, we need to use both equations. So now I'm going to take this second equation and use it for step 2. So I'm going to write that down, y equals negative 3x minus 6. And again, I'm going to put a box around the same variable, okay? So if y is boxed over here, that's what I isolated, then y is going to be boxed over here. Now your directions say to substitute the value for one of the variables into the other equation. So that means I'm going to take 2x plus 4 and I'm going to put it in the place where y is. All right, I'm going to substitute. I always usually substitute in parentheses because that's a quantity. You'll see it won't really make a difference in this problem, but it's a good idea to do that, okay? So now, because y was equal to 2x plus 4, I can put that in place of where y was, and my equation is now 2x plus 4 equals negative 3x minus 6. I've combined the two equations. Now we have to solve that equation for the first variable. So when I solve this, I can actually remove those parentheses. I don't need them here, but I need to combine like terms. So I'm going to add 3x to the left and to the right. So 5x plus 4 is equal to negative 6. Then I'm going to take away 4. So 5x is equal to negative 10. Divide by 5. And x is equal to negative 2, right? So that is my first variable. If you remember, what we're looking for is a solution. So we're trying to find the point where these two lines intersect. So that's the x value of that point, okay? Then we're going to come over here and we're going to substitute that answer into one of the other original equations. It does not matter which one you put it back into because remember the point is the same on both lines. So if I take the first equation, 2x plus 4, and I know x is equal to negative 2, then I'm going to put negative 2 in where x was. And now I just have to use PEMDAS. Well, 2 times negative 2 is negative 4. Negative 4 plus 4 is 0. So I've solved the equation for the second variable, okay? So the last step is to state our solution as a coordinate. So it's x comma y, so negative 2, 0, right? And then verify our solution. So you can verify using Desmos, which we'll show you in a little bit, or you can verify by substitution. So if I take both equations Now I can put in -2 for x and 0 for y. So it would look like 2 times -2 plus 4. Double check your math and make sure that equals, right? And then the second one, again, 0 for y, -2 for x. Double check that that math equals, and it does, right? So if both of them check out, that means that we were correct. We verified our solution. If one of these did not equal out, that's when it's that means we made a mistake somewhere, okay? So that's the first example where the equations were both already isolated for you, the variable originally. Let's look at one that's a little bit more complicated. These two equations are in standard form rather than slope-intercept form. So we're going to follow our same steps and see if we can solve this system. So again, first step is to isolate one of the variables. Let's look for a variable that has a coefficient of 1 or 2. Well, if I look right here, y has a coefficient of -1. So that's what I'm going to choose to isolate. Remember, it could be any of those 4 variables, but I'll choose that one because it'll be the one that will give me the least possibility for fractions. So 2x minus y equals 12. I'm going to isolate the y, all right? So minus 2x from both sides. So -y equals 12 minus 2x. And remember, this is like a -1 here. So I'm going to divide everything by -1. So y equals -12 plus 2x, all right? So that is my quantity. I'm going to put the box around y because that's what I isolated. And now remember, if I use this as my first equation, now I have to use this as my second equation. So for step 2, I have 8x plus 4y equals 16. I'm going to take what I found for y, and I'm going to substitute it into the y value right here, right? I'm going to put a box around that same variable. Okay, so this becomes 8x plus 4, but then in parentheses, this is why it's important to have parentheses, I have -12 plus 2x, all right? And that's equal to 16, okay? So finish that equation. So you're not replacing the 4 that's connected to the y, just the y, all right? So this becomes distributing, so 8x minus 48 plus 8x equals 16. I'm going to add 48 to both sides. You can do it in a different order, remember, but that's what I chose to do first. So that's 64. 8x plus 8x is 16x equals 64. Divide by 16. Whoa. One too many lines there. And so x equals 4. Okay, so that is the value of the first variable. We just substituted and then we solved, all right? And now we're going to substitute again. So I'm going to take x equals 4, and I'm going to put it back into one of the original equations. Your other alternative is to put it back into this equation you created. Because y has been isolated, that's actually a little bit easier for me. So I'm going to go ahead and try that. So -12 plus 2x. So y equals -12 plus 2 times 4. Y equals -12 plus 8. Y is equal to -4. So that's the value of the second variable. Now we just have to state our solution as a coordinate. So this is the point 4, -4. And you can verify with substitution algebraically. I actually want to show you how to do it graphically. Oops. So really quickly, I'm going to put these two original equations in here to Desmos. 8x plus 4y equals 16. Oops. Make sure you get the y. And then 2x minus y equals 12. All right. Once those equations are in there, I'm going to hit the double arrow to give myself a bigger screen. And then you can move around the graph until you get it where you want. If you end up zooming way too far out and you're like, uh-oh, just hit the little home button and it'll take you back home to a 10 by 10 window. But then we want to look at where these two lines intersect. Go ahead and tap on that point and it tells you 4, -4, which is the same solution here. So I'm going to write that I verified with Desmos, and it was in fact the same. If those points were not the same, then I would have to go back and check my work. But here I showed that I could graph it or I could solve it with substitution and I get the same answer. All right. So make sure you have these notes down. I'll post a copy of this to underneath the video, and then you want to work on your substitution practice set.